welcome to my series on microelectronic circuits. I wanted to make this brief video to introduce the course. I just completed the course at my university and I found the material really interesting. And I'm just hoping to help other students by making videos with examples and explanations of the concepts. Maybe if you guys are taking the course as well. Do keep in mind, I'm not a professor, I'm a student. So if I make any mistakes and anything like that, please let me know. Before we dig in, it's important to recognize that the material that I'm about to cover requires an understanding of like a regular circuits course, perhaps like a circuits 1 at the university you're at. So I'm just going to briefly touch on the important concepts from circuits 1 just before we get into the other material. So it's important to know linear circuit elements. So that's like resistors, maybe capacitors, inductors. It's important to understand how they work. Maybe you'd be familiar with like the current and voltage characteristics, if we make like an IV graph. If you don't really understand this, I suggest kind of looking into some tutorials on that first. So another thing that's important to know is all the different types of sources. Maybe like some, your ideal current source. You've probably seen this, I hope. Maybe a voltage source, perhaps a dependent source. It's important to understand how they work and your power calculations. As you know, whenever you do that power equation, you're going to get a negative for something that's developing power as opposed to absorbing power like a resistor. So that's something that's important to keep in mind. Also, it's important to know your source transformation. And the transformations I'm talking about here is your Thevenin and Norton equivalents. So if you know your Thevenin and Norton equivalents, that's important. It'll come in really handy. And then it's important to know circuit analysis techniques. So that would be like KCL, KVL, node voltage, mesh current, etc., etc. And these might have, they're sometimes called differently depending on how you're taught. But if you're able to analyze, some simple DC and AC sources with the techniques, then you should be good to go. And then the last thing that is on the list of things to know is a little unique because it is more on the electronics side, so not every Circuits 1 course would cover it, but it is the ideal op-amp. So microelectronic circuits has a lot to do with operational amplifiers. We're going to talk about op-amps in detail. So it's just good to understand how an ideal op-amp works and how to analyze a circuit that has an ideal op-amp. And if you understand that, that'll help you a lot later on. All right, moving on. So if you're comfortable with those concepts, everything, then you should be good to go. And what this course is going to be dealing with, I'll use a different color here, orange, is going to be various nonlinear circuit elements. So that's going to be things like diodes, MOSFETs, BJTs, and more. And then we're going to have like an extensive discussion of op amps, just like I was saying before. So non-ideal. And then we're going to be talking about your analog. This is kind of what the course is split into. There's like an analog section of the course and then digital circuits. And we're going to talk a little bit about like logic gates and all that good stuff. But I'm not going to go into detail right now. This is just meant to kind of introduce the material. But in the next video, I'll go ahead and get started with the first nonlinear element, which is going to be a diode. So I'll see you guys then. Have a great one.